Hello and welcome to lesson 3.2, U-mix cubes. Okay. So let's go. Ready, set, go. Let's start off with number one. Use this graph to write an equation of the quadratic function. Okay. So there's several ways to write a quadratic equation from a graph. Sometimes you'll talk about vertex form. Um, vertex form. Or I would call this a factored form. Um, factored form, factored form. And today, I think it's important to realize that this vertex, it's not easy to tell what it is, right? So I don't want to eyeball it. I don't want to have a rough estimate. I want to have an exact equation for it. Um, so what I'm going to do here, let me make sure my microphone's on. Yes, okay. It's going to look at the solutions. So at the roots. So this is a root and this is another root, okay? So in factored form, we want to have this as y is equal to a, that's your leading coefficient, right? Okay. X minus root 1 times x minus root 2, okay? So R1 is a root and then R2 is another root, okay? So a root is a solution, remember that. So these are solutions to this quadratic function. So let's kind of identify here first that we have, this is right here is at -2. So R1 is equal to -2, and then R2 is equal to 3. Okay? So then we can have that this is going to be equal to y is equal to a leading coefficient, right? We'll solve that right now. X minus -2 times x minus 3. So really quick, here we can simplify this to make it look nicer. Y is equal to a, x minus a negative, right? This becomes a plus, so it becomes x plus 2, x minus 3, okay? Now we need to see if we can use this a. So how do we solve for a? Okay, so to do that, pick a point and plug it in. So I want to use this point. Let's say this is 2 comma -4. So this means that when y is equal to -4, a is what I'm trying to solve for. I'll plug in 2. So 2 plus 2, and then 2 minus 3. So -4 is equal to a, 4. 2 minus 3 is -1. So now I get that -4 is equal to a times -4. Divide this by -4, divided by -4. I get that a is equal to 1. Okay, so my leading coefficient here is just 1. So then my actual equation of this quadratic function is y is equal to x plus 2, x minus 3. Okay, good. Let's talk a little bit about, let's make this color. Good, a is equal to 1. We don't write 1. You can write a 1 here, but standardly, we don't really do that, okay? Okay, let's move on to number 2. So very similar here. We don't have a vertex. We can't get it off, but we do know our roots right off the bat here. So y is equal to a, x minus r1 times x minus r2. Okay, so let's identify our roots. So here we have this is -4 comma 0, and then we have -1 comma 0. So then r1 is equal to -4, and r2 is equal to -1. So then we have y is equal to a, x minus root 1. So x minus a negative will become a positive, so plus 4. And same thing here, x plus 1. Okay, now let's go ahead and solve. We need to make sure that this value is 1 or positive 1, right? We want to make sure we want to find what it is. So let's use a point that we like. So I can see several different points here. I want to use one of the easiest points, I think, is this one right here. This is 0, comma 4. That means that my y is 4, so 4 is equal to a. What's my x? My x is 0, so 0 plus 4, 0 plus 1, 4 is equal to a, 4, 1, so 4 is equal to a times 4, so then divide this by 4, 1 is equal to a. Okay, so my equation here is equal to y is equal to just x plus 4, x plus 1, okay? This is it, right here. Perfect. Let's move on to question 3. Okay, so it looks a little bit different, but not really, right? So again, we can use this vertex, but for the purpose of today, we're not going to talk about that. Let's put them all into factored form. That's what I want us to get at, okay? So today's factored form, we have here, and these are our roots, okay? So we can have that this is equal to, y is equal to a, x, this right here is negative 6 comma 0, this is negative 2 comma 0. So my root 1 is equal to negative 6, root 2 is equal to negative 2, x plus 6, this is x plus 2. Okay, so we're close. Now let's go ahead and solve for a. So how are we going to do that? So you have to pick a point. So I like this point over here, 0 comma 6. Okay, whenever you can plug in x equals 0, that's beauty to us. Okay, music to our ears. A, 0 plus 6, 0 plus 2. 6 is equal to a, 6, 2. So this is a little bit different, right? What do we have here? Now it's going to be that a 6 over 12 is equal to 1/2. So now we know that a is equal to 1/2. So we have 1/2 x plus 6, x plus 2. And then how can we check our work? How do we know that this is correct? We plug in another point. Okay, so another good point that I have, let's say this one. So this is a negative 4, comma, negative 2. So we can plug in negative 4. So 1/2 negative 4 plus 6, negative 4 plus 2. This is 1/2. This is 2. This is negative 2. So this is all equal to negative 2. Right? So does negative 2 equals negative 2? Yes. Okay. So then we know as a result that this is our correct and final answer. Okay. Let's talk about 4. So 4, very similar, right? And we want to find our roots. So we have a root here and a root here. So a root is when it crosses the x-intercept. We want to find our intercepts first. So then my root 1 is equal to negative 4. My root 2 is equal to negative 1. I have y is equal to a x plus 4, x plus 1. Okay. Where am I getting those values from? Okay. So I know that my factored form is supposed to be x minus r1, x minus r2, right? But if I have a minus negative 4, this becomes a plus 4, okay? Is equal to x plus 4, okay? Now let's figure out another point. So I like this point right here, 0 comma 1. So then we're going to solve for a now. So I have that 1 is equal to a, 0 plus 4, 0 plus 1. So 1 is equal to a, 4, 1, and then 1 is equal to a times 4. Divide this by 4. I got that a is equal to 1/4. So then over here I have y is equal to 1/4 x plus 4, x plus 1. Okay. This is our final answer, okay? Let's talk about 5. Ooh, okay. These look a little bit different, right? They're not, what's so different about them? Okay, so I encourage you to think about that. What is so different about them? Okay. Same concept though. So factored form. Let's talk about factored form. I have y is equal a x minus r1, x minus r2. Okay. So let's look at our solutions, our roots. We have one here and we have one here. So then r1 is equal to -3, r2 is equal to +3. Okay, let's do it. Y is equal to a, my leading coefficient, I don't know what it is yet, x plus 3, x minus 3. Okay, now let's plug in our value. So we have the vertex here, this is 0, 9. So I can plug in y is 9, a is 0 plus 3, 0 minus 3. So I get that 9 is equal to a, 3, -3. So I get that 9 is equal to a times -9. I divide this by -9, and I get that -1 is equal to a. So then my final form, or sorry, my final equation is y is equal to negative x plus 3, x minus 3. Okay? This is important to realize that there has to be a negative there because this parabola is opening up, right? Opposite, right? So we see that it's not like this, it is essentially like this, okay? It's upside down, I would say. So that's something that's why we have this negative coefficient on there, okay? Let's do the next one. So again, you look at your roots. We have roots there, and we have roots there. So r1 is equal to -7, and my root 2 is equal to +1. I have y is equal to a, x minus -7, x minus 1. Y is equal to a. This becomes x plus 7, x minus 1. Okay, and I want to pick a point. I can pick this point, or I can pick this point right here. I'll pick this one, 0, 7. Okay, so I have that y is equal to, sorry, not y, 7, because I know that that's y. Y is equal to a, 0 plus 7, 0 minus 1. So I get 7 is equal to a, 7, -1. I get 7 is equal to a times -7. Divide this out, and I get that -1 is equal to 8. This is my leading coefficient, right? So then I have to bring this up over here. So then my final equation is y is equal to negative x plus 7, x minus 1. Okay? And just because this is the last one, I'll show you how to do a different point. So if I didn't like 0, 7, I wanted to use, let's say let's use this one. Let's use this vertex. So this is a -3, 16. Okay, let's see. Hopefully we get the same answer, right? We're supposed to. So that means that at 16, so this is my final answer. But using another point, if I say this is 16 is equal to a, -3 for x plus 7, -3 minus 1. So I get 16 is equal to a. This right here is 4. -3 minus 1 is -4. So I get 16 is equal to a, -16. Divide this by -16. So then a is -1. Okay, so we get the same answer for a. Okay, so very, very, very nice. That's kind of the first 6 problems. Okay, so again, if I give you the solutions of the roots, if you can clearly see the roots, write them as a factor form. Okay, so if you can see the roots, write it in factored form, then use a point to solve for the leading coefficient. How do you spell that? Coefficient. There you go. Cool. A x minus r1, x minus r2. Okay, this is my factored form. Let's talk about 7. Okay, what are the y-intercepts for the graphs in problems 1 through 6? Oh my goodness. Okay, so let's pick a best way to do this. So, I mean, going through all of these, the y-intercept here, I'm gonna have to use, let's use a highlighter here. Let's use some red. So, this is my y-intercept there, nope, not there, my right there, y-intercept, y-intercept, y-intercept. A lot of them I already used them, right? So let's kind of make a list here of our values. Let's say at number 1, my y-intercept there was 0, comma, -6. At number 2, and again to clarify, a y-intercept. So y-intercept happens when y-intercept is when x is equal to 0. Okay, that's important to note. So y-intercept always happens when x is equal to 0. We have 0, comma 4, right? So 0, comma 4 was right there. Oh my god, this is wrong. It's here, 0, comma 4. The next one was 0, comma 6. So number 3 is 0, comma 6. At number 4, it was 0, comma 1. Okay, we saw it there. Number 4 was 0, comma 1. Number 5 was 0, comma 9. 0, comma 9. And then number 6, last but not least, was 0, comma 7. Okay, 0, comma 7. Okay. In problems 1, 2, the y-intercept, okay, is just the product of the x-intercepts. So the x-intercept are the roots. Okay. Why isn't that the case for problems 3, 4, 5, and 6? Okay, so for 1 and 2, what does that mean? So for 1 and 2, the y-intercept here at 0, -6, right, was a product of the x-intercepts. So what was my roots? So you see how they multiplied -2 and 3? So for example, here it was at so it was negative, so it was let's do -2 times 3 was -6. That's how they got that was my product of, right, of the y-intercept. And for 2, they multiplied -4 and -1. -4 times -1, which is equal to 4. So that's a true statement, right? Why isn't that the case for problems 3, 4, 5, and 6? So let's think about problems 3. So here we have that there's a -6 and a -2. If you multiply them out, you would get positive 12. But that's not true, right? So for number 3, you get that this is -6 times -2, which is equal to 12. But my y-intercept is supposed to be 6. Okay? So what happens there? What would need to happen? Because there's a what? There's a scale factor. Okay? This isn't the case for 3, 4, 5, 6 because the leading coefficient is not simply 1. Okay? Okay. Okay. So we've done the ready part. Let's do the set. Okay. So complete the tables for f of x equals x, g of x equals x cubed, and h of x equals x to the fifth. Okay, so pretty straightforward for letter A. We're plugging in that f of -1 is just equal to -1, so -1. F of 0 is equal to 0, and then f of 1 is equal to 1, right? Because I'm just plugging in this x, goes in here, which is equal to this x, okay? Now let's think about g of -1 is equal to -1 cubed, which is equal to -1 times -1 times -1. This is -1, okay? So this is 1 times -1 is equal to -1, okay? G of 0 is 0 cubed, which is going to be equal to 0, okay? And then g of 1 is equal to 1 cubed, which is going to be equal to just 1, okay? This is 1. Now, h of x is x to the fifth. So I have h of -1 is equal to -1 to the fifth, which is -1 times -1 times -1 times -1 times -1, right? Okay? So we can break this up into, this is going to be 1. This right here will be 1. So then 1 times -1 will be equal to -1. So this right here, we get -1. H of 0 is equal to 0 to the fifth, which is just equal to 0, 0. Then h of 1 is equal to 1 to the fifth power, which is equal to 1. Okay? Okay. So what did we notice just off the bat? They're all the exact same points, right? Which is really interesting. 3 different functions. So there's 3 different functions, but they have the same -1, 0, and 1. They have the same points. So what does it mean? What does it mean that they're all the exact same? Think about that. Well, it means that at those particular points, at -1, at 0, and at 1, the graph intersects. All 3 graphs, okay? So this means that all 3 graphs intersect at those 3 points. And what are the points? So -1, comma -1, 0, comma 0, and 1, comma 1. Okay, so that's important to note. Use the grid to graph f of x equals x, g of x equals x cubed on the interval, and h of x on the interval. So a lot of us might get scared as to like, what does this mean? What does this mean? Like, okay, all that just means is that you're graphing between -1 and 1, okay? And it's a little bit more straightforward than we might think, right? We already have the tables. So I want to use the tables above, okay? So I'm going to graph f of x equals x. So at -1, at -1, I'm at -1. So this is my first one. At 0, I'm at 0, and at 1, I'm at 1 right here, okay? So my first point will start here, and I'm going to go right up to there, okay? So this is f of x. So f of x. Let's use a different color. Let's think about x cubed. So g of x, same concept, right? They're the exact same. So at here, here, and here. But we need to think about how does g of x behave? Okay, so it's a cubic function. So it should look something a little bit like this. Okay. And I'm not the best at drawing. This looks a little horrible. So something like this. Okay, that's fair. So that's my g of x. G of x. And last but not least, I need to think about how h of x looks like, right? So h of x is a quintennial function, which we probably haven't really explored much. But, okay, so h of x look something like this, and then like this. Okay. This is h of x. Okay. I encourage you to think about this a little bit more. Um, you can make a table of values that include fractions. I didn't really do that. I kind of just eyeballed it. You can also graph these. So let's go ahead and graph these just for our sanity and our sake of learning. Oh my goodness. So let's go here, clear these up, clear these up. Okay, so I have x cubed, and enter, and I have x to the fifth power. And I'm gonna go ahead and go to my window, and I'm gonna change this to negative 1.25, and then 1.25, and let's do scales of let's whatever, and then minimum of negative 1.25, and then positive of oops, 1.25. Okay, let's do that. Let's graph this. Okay, cool. So this is kind of what we see. We see that the green one is x cubed, right? So x cubed is h of x, a little bit higher, and then we see that, yeah, perfect. Okay, so this is between -1 and 1. I'm not going to screenshot this and put it there, but if you're looking at the video, this would be helpful. Okay, um, let's think about 12. Okay, so fill in the blanks with f of x, g of x, and h of x to make a true statement. Okay, so in the interval between 0 and 1, so we're only caring about this part right here, between 0 and 1. 0 and 1. Okay, so which one is greater? So let's start off with that one. Which one is the greatest one between 0 and 1? That's f of x, right? So f of x is here. F of x is greater here. Between 0 and 1, f of x is above everything else. And then we have that g of x, and then the smallest is h of x. Okay? Now between 1 and infinity. So we kind of need to think a little bit about if this were to go on forever and ever, right? So think about it in this graph. This h of x will go here. But then g of x and h of x would be going up, okay? And h of x is going to be going up faster. So I can easily look over here on my calculator, and I see that the green graph, in the long run, the green graph, h to the fifth, is increasing more, right? So then h of x here, f of x is my smallest, and then g of x is in the middle, okay? So that should be a little bit intuitive. And why is that? Okay, so x to the fifth will grow, or will grow faster. Faster. Between, oops, between, how do you spell between? Between faster on 1 to infinity. And why is that? So let's just think about it. Think about it on a very small scale. So if I have, let's just think about 2. So if I have 2 cubed, that's equal to 8. But if I have 2 to the fifth power, that's equal to 32, right? So automatically we see that h of x is greater. H of x is increasing faster, okay? I hope that made a little bit of sense, okay? Again, you should use your graph, and you can also graph that. But I think the point that I'm trying to get at is that h of x has a higher power. So a higher power will be increasing more rapidly when x is greater than 1. Let's just say that, okay? Okay. Now, use the grid to graph f of x equals h of x, g of x equals x cubed, and h of x equals x to the fifth on the interval between -2 and 2. Oh my goodness. Okay, so let's think about what that would look like. Just because, okay. So I don't know what's the best, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so let's just kind of pretend that I'm splitting this up in the middle. And then I'm going to split this up right here. Okay, so this is going to be one line here and one line here. It's 0, 0. Okay, let's do this right here is -1, and this right here is -2. And let's do 1, 2, 3, +1, 1, 2, 3. This right here is 2. Okay, I really don't like this problem. I would say it's okay. Let's do it. We are going to be experts at graphing. Okay, so then on a little table, I want to just finish off my values, right? So I have x's, I'm going to have f of x, uh, and I'm going to have a table here, g of x, and I'm going to teach you how to do this by hand, and then we're going to do it all in the calculator by just changing our windows. Okay, so -2, -1, 0, 1, 2. So we know that this is -2, -1, 0, 1, and 2. Okay, so let's think about -2 to the cubed power. Oops, I should have made these. Oh, nope. So -2 to the cubed power, we're going to get, that's going to be -2 times -2 times -2, -8. Okay, and I'm really going to kind of copy what we have already because we know that it's a -1, 0, 1. So -1, 0, 1. This is going to be 8, right? And I already talked about this over here a little bit. How now we have h of x, so this would be -32, -1, 0, 1, and then at 2 we are at 32, +32. Okay. So then I'm going to use the same colors that I used over here, or try my best at least. So at -2, I'm going to put it at let's just use -2 here, and then -1, and then 0, and then at 1, I'm going to be at 1, and then at 2, I'm going to be at 2. So this is my first function, okay? And I'm going to have g of x at -2, I'm going to be down here at like -8, 1, 2, 3, 4, 5, 6, 7, like right here. I'll use my other color for this. What color did I use for that one? I used the pink. So right here, 2, 3, 4, 5, 6, 7, 8. Cool. And then at -1, I'm at 1 here, and then I'm back at 0. I'm back at 1. At 2, I'm all the way up to 8. So it looks something like this. Okay. This is my g of x. And now my h of x that I need to do. At -2, I'm going to be way down here. Let's pretend that that's kind of where we're at. Some values will be off the grid. That's fine. So I'll do that. And then I'm going to go at here, here, here. And at 2, I'm at 32. So at 2, I should be way up here. Okay. So let's do something like this. Horrible. Here, here, here. And then a law faster. H of x. Okay. So pretend those graphs are perfect, even though I know they're not. And I would also encourage you to use your calculator for kind of just seeing where we're at. And let's do our window, and let's change it here to oops, let's go here and change this to a -2, 2, 2, and 2. And now let's graph that. So we see that this is our bigger scale between -2 and 2. Okay, let's do back here. Oops. Okay, not want it. Okay, so sure. Yeah. So that's kind of what I want us to kind of think about. That okay, and it overlaps it up here, and then it goes on. Okay. Sorry, I didn't do the best job here, but um, the graphing calculator is more beneficial. Okay. Now we're ready to go for the Go section. So at the Go section, we're using our properties of exponents to multiply. So I like to use the MA, so I like to call it mat spam, mat SPM. So when you multiply, you add, multiply, multiply, I add, when I divide, I subtract, and when I take them to the power, I multiply them. Multiply. Okay. So here I am multiplying all these exponents, so I need to add the exponents, right? So I'm going to be left with x to the 1/3 plus 1/6 plus 1/4, and it essentially just becomes a matter of combining like terms. Sorry, of adding fractions, I mean. So then let's think about finding a common denominator. So for all of these 3, 6, and 4, I think 12 is what works fine. So we have 12, 12, 12, 4, 2, and then 3. So I get that this is 9/12, which is equal to 3/4. So this becomes x to the 3/4. Okay. Same thing here. I'm going to add them up, right? So I'm adding exponents, so I add the exponents. 2/5 plus 3/10 plus 2/15. So I think 30 is my magic number. Where am I getting 30 from? So I need to think about the common multiples. So the least common multiple of 5, 10, and 15 is 30. Okay, so this is going to be times 6. This is 12. This is times 3. So this is 9. This is times 2, which is 4. Okay, so I'm going to spend a lot of time here. 12 plus 9 is 21. 21 plus 4 is going to be 25. This is 25 over 30, which is equal to 5/6. Okay. This is a to the 5/6. Okay. Same thing here. I am adding those fractions up. There must be a better way of doing that. I'm not gonna really do it. 4/7 plus 3/14 plus 5 over 28. And my least common multiple of all of these is exactly 28, right? So then you need to think about 28. So 7 times 4 is 28. So I need to multiply the top and the bottom by 4. So I get 16 plus 14 times 2 is 28. So I multiply the top and the bottom by 6. And then 20, last one just stays the same. This is 5. This is 16 plus 6 is 22. 22 plus 5 is 27. So this is 27 over 28. So I'm left with m to the 27 over 28. Okay. I didn't really go over how to really add fractions. You should be familiar with adding fractions, and if you do need some help, please feel free to message me. Okay. This is a new concept for most of us. So the conjugate of each complex number. So what exactly is the conjugate? What is the conjugate? So in simple terms, this is a simple question, right? It looks more difficult than it actually is. The conjugate of A plus BI, the conjugate is just kind of the opposite. The conjugate is A minus BI. That's all it really is, okay? So for 18, the conjugate just means that I change the sign. So the conjugate there is -5 minus 2i. Okay, so this is generally my final answer. And here I have 23 plus 89i. And then here I have that this is -4 plus 17i. Okay, and then if I have A minus BI, the conjugate is A plus BI. Okay, and then here, let me highlight these answers. Let's write it more clearly. A to the 5, 6 here, and this is M to the 27 over 28. Okay, that was the last one. I hope you all have a great rest of your day and enjoy.